Hello, AP Physics 1, it's Mr. Ng with number 27 in your momentum review packet. Let's dig right into it. A stationary object explodes, this is a keyword, breaking into three pieces of mass m, and 3m. And the two pieces of mass m move to the right angles as shown above. And it wants to know the magnitude and direction of the 3m piece. So the majority of this problem is going to be just dealing with vectors, but there is one big idea that we should know about explosions. In an explosion, the sum of all the momentum is going to equal to 0, meaning all the vectors, if we add them all together, considering their directions, should equal to 0 because it started out stationary to begin with. Just conservation of momentum when you think about it. So I'm going to do myself a favor and reduce this down. Instead of adding three things together, let's add two of them together first. So here, let's find the resultant of these two vectors, right? Let's find this resultant, which I'm going to call C because of Pythagorean theorem. If we recall, 1 and 1, a squared plus b squared is equal to c squared. A squared plus b squared is equal to c squared. So 1 plus 1 is equal to c squared. So c is equal to the square root of 2. So now I know that this is basically the square root of 2 times this. So c, or our resultant, is going to be the square root of 2 mv. Simple enough. So now I just need something. So we know that we have one explosion going square root of 2 mv. So the other one must go in the opposite direction with the exact same magnitude, right? So this needs to go with the same magnitude. So square root of 2 mv is going to equal to 3m v. See, this is the equation for momentum. This is my sum of the vectors of the other momentum. And I just set them to equal to each other. Makes sense? So because the velocities are going to goof us up, let's call this big velocity. And I'm just going to put a little dash there to say that this is the velocity of the moving object. And this is the velocity that, this is a value that the velocity should add up to, right, based on the initial velocity. Good? So now all I got to do is solve for this velocity prime. So velocity prime is going to be equal to square root of 2 mv divided by 3m. These m's cancel. So the velocity of that piece is going to be the square root of 2 over 3v. So if you look into your key, I think that one is, the answer is D. Thanks a lot for watching. All I did was use the idea that the sum of vectors in an explosion becomes 0. I found the sum of these two vectors, right, these guys here, and then I took that value, which is square root of 2 mv, and then I made that equal to my regular old momentum equation, which is mv, or m times v. In this case, it's 3mv because it's 3 times bigger. I set them together. I solved for my new v, and I got square root of 2 over 3v. Thanks for watching. Bye-bye.